Hello everyone, and welcome back to the video series Deep Learning for Teens. In this video, I will explain how an ANN is built. Before we begin, I want to clarify this video is mainly exploring how an ANN works, and we will not be writing any code. If you're trying to write code to develop an ANN, then part 5 of this video series is for you. In this video, I will explain how this network is built, along with how it works. It will be trained to recognize handwritten digits. If you have not already seen it, I recommend watching the previous video in this series. In that video, I describe how a single artificial neuron works. I also describe how these artificial neurons can be used to construct an artificial neural network. You will need to understand these concepts for this video. In this video, we will build a network to recognize images in the MNIST dataset. These are images of the handwritten digits 0 through 9. It is a free dataset that contains 60,000 images, just like these on screen. Here is an example of an image from the MNIST dataset. This is an image of the number 5 that someone wrote. You will notice that the image looks very boxy. In fact, the image is made up of a large number of boxes, as shown by the yellow arrows. Each box has a single color and is known as a pixel. The image is 28 pixels wide and 28 pixels high. Each pixel has a value between 0 and 255. 0 represents complete black, while 255 represents complete white. Values in between are different shades of gray. Lower values close to 0 are darker, while higher values close to 255 are lighter. If we remove the shading for each pixel, we are left with a series of numbers. This is how the image is stored in a computer. This series of numbers is what we want to send into our deep learning network. There is a problem with sending these large numbers into our neural network, though. Do you remember the sigmoid function I talked about in the previous video? Well, if you look at that function, you will see that if we give it a value outside of -5 and +5, as represented by the red arrow, the output of the function does not change. Because of this, sending in a high value like 254 in the image is a problem. To fix this, we divide all the pixel values by 255, and then get numbers between 0 and 1, as you can see in this picture. These numbers now work well with the sigmoid activation function. This process of changing the image pixel values from having a max of 255 to now a max of 1 is known as normalizing. This has to be done whenever the input to an ANN is large. If we take the normalized MNIST picture of the number 5 and assign white to 1 and black to 0, you will see that the shaded image still looks exactly like our original image. We will now build a network that can process these normalized images. We will start with an MNIST image. Each image is 28 pixels wide and 28 pixels high. This means that each image has 28 pixels multiplied by 28 pixels, which is 784 pixels in total. We will take all the pixels in an image and line them up in a single column. I have shown how the first 2 pixels of the image are sent to the lined up pixels. Each pixel is fed into a single input neuron in our artificial neural network. Because there are 784 pixels, there will also be 784 input neurons. Next in our network, we have 128 hidden layer neurons. Each hidden layer neuron receives information from all the input layer neurons. Here are the connections to the first hidden layer neuron from all the input layer neurons. Here are the connections to the second hidden layer neuron from all the input layer neurons. Here are the connections to the third hidden layer neuron from all the input layer neurons. Here are the connections to the last hidden layer neuron from all the input layer neurons. As you can see, all the hidden layer neurons are connected to all the input layer neurons. Finally, we have the 10 output layer neurons. Each output neuron represents a digit between 0 to 9. All the output layer neurons are connected to all the hidden layer neurons. In a future video, I will show you how to implement this artificial neural network using TensorFlow on Google Colab. TensorFlow is a very popular tool developed by Google to implement deep learning models. Google Colab is a free online website intended for simple machine learning development. The text on the right shows how this network is described in TensorFlow. The 3 lines in the red box describe the 3 layers of our network. The input layer is known as a flattened layer because the square input image is flattened into a single line. You can see that the description of this layer in TensorFlow uses the word flatten and also specifies the input image size, which is 28 by 28. The next layer in our network is known as a dense layer because it has a dense connection of all neurons in this layer to the previous layer of neurons. The TensorFlow description for this layer uses the word dense and has the number 128 to specify the number of neurons in this layer. The neurons in this layer use the ReLU activation function as shown in the model description. The output layer is also a dense layer, so the TensorFlow description also uses the word dense and has the number 10 in it as this layer has 10 neurons. There are 10 neurons since there are 10 outputs in our case, which are the digits 0 through 9. In the next video, I'll describe the process by which this ANN learns to recognize the MNIST digits. This process is described as training the network, and I hope to see you then.